More on special angles. Remember, these angles are the ones that come up the most during trig. And so it's important now that we know not only the degree measurement of these angles, but also the radian measurements. Let's fill in what we've already learned. We know that 360 degrees is 2 pi radians. Of course, that has the same terminal side as 0 degrees, and the same thing holds for radians. If I don't rotate at all, I wouldn't have any arc length. My S would be 0, which means the radian measurement would also be 0. So 0 degrees corresponds to 0 radians. We've also said that 180 degrees corresponds to pi radians. Everything else in this picture can be proportioned out from these values. Let's take the other two quadrantal angles that are shown here. If half a rotation takes me to pi radians, if 180 degrees is pi radians, then 90 degrees would just be half of that. 90 is half of 180, so half of pi, 1/2 pi, which we like to write pi over 2. Well, once I know that 90 degrees is half of pi, or pi over 2, I can just count by 1/2 pi's every time I move 90 degrees. So half a pi, and then 1 pi to get to 180, and then 1.5 pi to get to 270. 1.5 pi. Now, we don't want to write it that way. 1.5 as an improper fraction would be 3/2. So this is 3/2 pi, or the way we write it, 3 pi over 2. We can write it that way because multiplying 3/2 times pi, if I put a 1 underneath, I multiply across, I get 3 pi on the top and 2 on the bottom, 3 pi over 2. Again, think about counting. It's such a useful idea. Half a pi up at 90, 1 pi at 180, 1.5 pi at 270, and then 2 pi with 1 full revolution. Let's move on to the angles that have to do with 45 degrees, the ones that are 45 degrees away from the x-axis. The first one is, of course, itself 45 degrees. Well, 45 is half of 90. So if I simply take half of pi over 2, that should tell me the radian measurement for 45 degrees. And multiplying across, I get pi over 4. 45 degrees is equivalent to pi over 4 radians. Or you might even think of that as 1/4 pi, 1/4 of pi. Well, once I have that one, it's easy to figure out the rest. Just count by 1/4 pi every time you make 45 degrees. So 1/4 pi, and then another 45 degrees would be 2/4 pi. 2/4 reduces to 1/2. So that fits with what we already have, 1/2 pi. Then would come 3/4 pi. So this one must be 3 pi over 4. And then 4/4 pi would reduce to pi, followed by 5/4 pi, in other words, 5 pi over 4. 6/4 pi takes me here. We already have that one. And then 7/4 pi, or 7 pi over 4, takes me here. If I went another 45 degrees, that's going to be a full rotation for 8 pi over 4, which reduces to 2 pi, and we already have that one. Again, you can see how powerful this idea of counting by 1/4 pi becomes. Okay, let's try the angles that are 60 degrees away from the x-axis, starting with 60 degrees. We know that there are 3 60s in 180, which means 60 is 1/3 of the way to 180. So 60 must be pi over 3. A quick check, right? Anywhere you see a pi in a radian measurement, mentally you can stick in 180 degrees. So just think to yourself, oh, this is like 180 divided by 3. Yep, 60 degrees. Again, we can use our counting technique. So 60 is 1/3 of pi, which means the next one here at 120 would be 2/3 of pi, or we write 2 pi over 3. Then comes 180, which would be 3 pi over 3. We don't write that because that simplifies to be simply pi. The next one here, another 60 degrees, would be 240. We're at 4 pi over 3 now, 4/3 pi, and then 5/3, or 5 pi over 3, for 300, and 6 pi over 3 would simplify once again to 2 pi with 1 full revolution. That leaves us with the angles that are 30 degrees away from the x-axis. We'll start with 30 degrees. 30 is half of 60, so half of pi over 3 would tell us 30 degrees. Multiplying across, that gives me pi over 6, or 1/6 pi. Now, I could do that same counting thing again to go around the circle, but just to show a different approach, let's try for 150 degrees over here. Well, notice that the difference between 180 and 150 is 30 degrees. So if I take 180 pi radians and I subtract 30 degrees, pi over 6 radians, whatever that answer is, that's going to be the radian measurement for 150 degrees. How would I do that? Well, I'd have to get a common denominator. I could do that easily by multiplying the top and bottom here by 6. So I'd have 6 pi over 6 minus 1 pi over 6, which of course would give me 5 pi over 6. 5/6 of the way to pi is one way to think about that. How about 210? Well, 210 is 30 degrees past 180. So if I simply redid this calculation but added the 30 degrees instead, that would give me the measurement for 210, and that of course would be 7 pi over 6. Let's see, the only one missing now is 330. 330 is 30 degrees short of 1 full revolution. So I would have to take 2 pi, 1 full revolution, and subtract off 30 degrees, pi over 6. Let's see, common denominator, multiply top and bottom by 6. That would make this 12 pi over 6, right? That reduces to 2 pi, minus pi over 6, which of course ends up being 11 pi over 6. We've now identified the radian measurement of all of these special angles, and as it says down here in the corner, these are values you really want to commit to memory. We're going to see them all semester long, and the faster you can see one of these angles and know the corresponding other measurement, the better off you're going to be. Let me mention some things that will be helpful along those lines. Take a look at the quadrantal angles along the x-axis. Notice that those are all whole values of pi. So I've got 1 pi going around half a rotation, and then 2 pi. Well, look, if I kept going, all that's going to happen is 3 pi, 4 pi, 5 pi, 6 pi, etc. They're all like that. Look at the quadrantal angles along the y-axis. The denominators are 2. They're all like that. If you went around multiple times, you'd get pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. They'd all have 2's in the denominator. I think you can see where this is going, right? Take a look at the angles that had something to do with 45 degrees. Well, if you look at those, you notice that all the denominators are 4's. It will always be that way. Those angles that are 45 degrees away from the x-axis, the radian measurements will always have a 4 in the denominator. The ones for 60 degrees all have a 3 in the denominator. And of course, the ones for 30 degrees all have a 6 in the denominator. Use that to help you in your memorization process. It becomes a quick way to recognize certain angles. Thanks for watching.